In this video, I'll be going over the basics of logarithmic functions. So a logarithm, base b of a positive number, x, satisfies the following. So if x is greater than 0, b is greater than 0 and not equal to 1, y equals log base b of x is equivalent to b to the y is equal to x. So what that means kind of in plain English is this is log form, and this is exponential form. And these are representing similar things, but what we're doing is these are inverses of each other. So the inverse of an exponential equation is the log equation, and vice versa. So this is one of the key things that we need to be able to do first, is convert between log form and exponential form. So what I always tell students is that logs equal exponents. Okay, so if I have a log like here, this y is what that's equal to, and that is the exponent. Kind of crammed there. But so on this first example, log base 6 of square root 6 is equal to 1/2. This 1/2 is the exponent, and the base is 6. So 6 to the 1/2 is equal to square root 6. Similarly, on number 2, 2 is the exponent, and it's the exponent for this base of 5. And then we call 25 in the log equation the argument. So that is what gets by itself in the exponential equation. Okay, and then let's go the other direction. 2 cubed is equal to 8. So the base is 2. So log base 2. Logs always equal exponents. The exponent is 3, so it's going to equal 3, and then the argument is 8. Similarly, log base 4, logs equal exponents. This is 256. So one thing to notice here is by converting to a log equation, we have isolated the x. Okay, so here, if we want to solve for x, one way to do that is just to convert it to a log equation, and then we've solved for x. And we'll talk about how we can find a real number value for log base 4 of 256. We'll talk about here in a moment. All right, so there's two main types of logarithms, a common logarithm and a natural logarithm. A common logarithm has a base 10. So base 10 like this. But when we have a 10 here, we don't write the 10 explicitly. So log of x, that means the same thing here. So those are equal. Okay. So when you type the log button on the calculator, that is log base 10. So if I wanted to convert this, y equals log of x into an exponential function, the base is 10. Log is always equal the exponent, so this is the exponent. And then, so 10 to the y is equal to x. A second type of logarithm that we'll see quite often is a natural logarithm, and that has a log base e. So log base e of x is the same thing as ln of x, and we call this natural log. So in the same way that log of x has an implied base, which is 10, ln of x has an implied base, which is e. All right, and then we can see how those get converted. Log base e of x is equal to ln of x, which is equal to e to the y is equal to x. Or that's how we convert it, I should say. All right, so let's evaluate some logarithms, and we'll do this without a calculator. So this first one, y is equal to log of 1,000. This means log base 10 of 1,000. Again, that's a common logarithm. Okay, so how you want to evaluate this is I would convert this to an exponential function. So this is 10. The exponent is y equals 1,000. So the question is 10 to what power equals 1,000? And that's y equals 3. So that's the value for that one. The next one, log of 1 over 100. So that's 10 to what power is equal to 1 over 100. This one maybe not as easy, but that's going to be y is equal to negative 2, right? 10 to the negative 2 is equal to 1 over 10 squared, which is 1 over 100. So y equals negative 2 on that one. And then lastly, we're going to have 5 to the power of y equals 125. Probably do that one in your head also. Y is equal to 3. So all of those come out to whole numbers. Let me look back here. Okay. And then if we want to go, all of those come out to whole numbers. That's not always the case, though, so we need to use a calculator for some of these. This first one says y equals log of 500, so it's 10 to the y is equal to 500. That one's not as useful to convert to an exponential function. So you can simply type in log of 500 on the calculator, and it'll calculate it for us. So I get a y value of 2.69897 about. Okay. Similarly, this one, the second one, means 10 to the y power equals 1 over 25. Can't do that one in my head either, so I can just type in log of 1 over 25, and we get negative 1.3979. Okay, the reason that this is negative is similar to what we saw up here in this second one, right? In order to get 1 over some value, I need a negative exponent, and that's what this is saying. And then lastly, ln of 20, what that means is e to what power is equal to 20. Okay, and you can just type that into the calculator as well. ln of 20, I get 2.9957. All right, and then we have this example. It says the amount of energy released from one earthquake was 500 times greater than the amount of energy released from another earthquake. The equation 10 to the x equals 500 represents this situation where x is the difference in magnitudes on the Richter scale. So, and then the question says, to the nearest thousandth, what is the difference in magnitude? So one thing to, if you don't know already, is earthquakes use something called the Richter scale to measure their magnitude, to measure how strong they are. And this is a base 10 log scale. All right. So as an example, if we experience two earthquakes, if one is magnitude 4 and one is magnitude 8, that doesn't mean they're the magnitude 8 earthquake is 2 times as big. What it means is, well, 10 to the 4th is 10,000. 10 to the 8th is 1 with 8 zeros. 4, 5, 6, 7, 8. And that number is 100 million. So 100 million divided by 10,000 is 10,000. So this is a long way of saying is this earthquake 10,000 times as strong as this earthquake. Okay, so it's not 4 times as strong, it's 10,000 times. And so when we say that something is a log scale, that's what it means. We're changing the exponent, not just multiplying by that value. Okay, so the equation 10 to the x equals 500 represents the situation of an earthquake that is 500 times greater than some other earthquake. To the nearest thousandths, what's the difference in magnitude? So we've actually already solved this up here. So the difference in magnitude is about 2.69. So what that means is the exponent, that's how the exponent is getting, what the exponent is getting multiplied by there.